Hello everyone, welcome back. In this part of the tutorial series, we'll be focusing on creating um, these support rods that you can see on the picture on the right hand side. Um, the way we're going to be tackling this, as you can see, it's quite complex, so we need to split this in parts in order to properly have all the rods uh, modeled in Grasshopper. Um, Briefly, there are four parts, maybe three. No, let's keep it to four. The first part being, if you look at the outer helix, for example, uh, which obviously are these, what you would notice that um, the support rods will connect from helix to helix. So from each major helix to each other until it winds up all the way to the other side. And that's one part, okay? The second part is basically the same, but for the minor helix, so it connects the other way around. If this is the minor helix, you can see that it actually connects in the same way, of obviously in the other direction, and then obviously between minor helix and minor helices, and the other minor helices. That's part two. So if I can actually briefly draw it, this is part one, and let's say that this is two, yeah. Part three is actually you may notice that we have still in between though, but that's a different part. Part three is going to be at the bottom of the helices. I'm gonna quickly browse through if I can have a picture that can showcase this. Let me see, perhaps this one should tell the picture. So as you can see, let me grab pen. This one. So as you can see, they connect between both helices, because at the bottom is where our helices meet each other. So as you can see, this one connects to this part here, and there is actually a rod that goes here and then goes forward. Where there isn't, for example, where at this point you would just see two rods that simply connects to the horizontal lines, and that just goes on and on and on. So you can see, I think if I can just still make out that part, I can still see that part, and obviously this part here, which again connects to that part. So I would say that this is three. Number four is, I think, is what you probably have guessed already. Uh, are the smaller ones that connects from minor helix to outer helix to the major helix, or vice versa. And they seem to connect in a very, well, chaotic pattern, but that's okay. As we go through along the way, I will explain to you everything and how they connect and how we can properly model this as close as possible. I didn't have enough time to obviously document all the connecting joints and uh, just look at exactly how they're made. I don't have that information, but I will try to model this as close as I can. And if you notice anything that's out of place, if you notice any discrepancies, do let me know in the comments below. So that will be part four. Once we have all these parts, we can say that we are about like 90% done with this bridge. In the last part, probably I'm just going to be tying up a few things, for example, like modeling these glass railings, and look at the design and see what we need to modify in order to make it as perfect as possible. So with that said, let's get on with part number one. Let's clean up all that, get this out, remind these. So this is what we left off last time. We had a base, we had a deck, which with the viewing parts attached to it. We have our support beams. We have the original minor helices, which we then modified because we had to accommodate this, the holes for the support viewing parts. we also have a base, of course. So the way I want to do it is I want to first separate the bottom from the top. And I think what we're going to do is, let's see, we'll probably need, firstly, we need all the points for that. That's for certain. So let me see. These are the lines. These are the points. These are the other line. Let me see. Well, I can probably just maybe, we can probably take this off from here and add it to the group. Yeah, I should just rename this to outer helix modify, perhaps. And we're basically doing the same thing as we've always done. So we're gonna take this off. I'm gonna put this somewhere here. So now that we have that part extracted, one thing that is probably worth noting is this small part right there, this almost horizontal part. Let's see, this part right here, this one. What we want to do is sort of isolate that, because this will give us a duplicate, because this part actually already exists, and it actually follows the same logic where you have the each ring will be connected to another. So what we want to do is you want to isolate that. You don't have to, but I would recommend you to isolate it in order to have a in order to have less things to worry about, in order to have less errors, potential errors. So we're gonna be probably using this part in order to get that out of the way. So what we can see is we need to identify which number it is, so we can actually quickly rule that out. I don't think it's this one. Nope. It was a very straightforward one. I'd probably say it's not that one. Oh, is it 1, 2? Is it this one? Nope. That one? Nope. Then which one is it? It's not this one. It's 3, but 3 goes to... Does 3 go here? That's weird. That's not even a line. Wait, oh, this one, I missed it. So now that we found the one that we actually want to exclude, what we can do is I actually want to change that, because what I aim to do is I want to have an output here where I can easily identify which one it is, so I can remove it. Or I can create two merges, one with and one without, but that just seems a bit, well, it seems a bit weird. So what I'm going to do is actually change our merge into an entwine. Because as you can see, look at that tree, the second branch has two branches, let's say. It goes 2 levels down before it reaches to the elements. So what I'm going to do is use the entwine. The entwine allows me to do is literally whatever input that goes in here will be its own branch. So I'm going to hold down Control and Shift so that I can replace these here, there. I might do that last, or actually let's do that first. So let's shift these down and put that one here and put this one there. And then we can actually, let's include this in here. I believe I might need to flatten that part. And now I have beautiful branches. So I can put that one there. And I can delete that and look at here. So the intent is, so if I can do, let's say, branch, or actually tree branch, what this allows me to do is, because I know it's in 0, I can actually come here and let's simplify this so I can just enter the tree 0, okay, and I will have that part selected, and not just this one, but all 4 of them, or however many you have, depending on the many of viewing parts that you have in there. So that's the easy thing we want to make for ourselves. With that selected, let's copy. Actually, let's do the same for our minor helices. So let's do an endpoint, and I think it's 3 is the one. Yes, I can see it highlighted in our viewport, and then just the rest you can order in the same way, but as of now I don't see the need to, so I'm not gonna do it. But if we do need it later on, we can just reorder this list and that'll be solved in that way. So I'm gonna include this. So I'm gonna do is take that and plug it in here. Oh, probably did something else. And then we're gonna call this inner helix modify, and let's put this like that. So now that we have these two selected, what I want to do is I want to shatter all these curves into their individual pieces in order for me to select the bottom ones from the top one, to isolate those. So if I select this one, oh yeah, let's exclude that tree that we isolate, which is that part over there, this small part. And the way we can do that is there are several ways. The easiest way would be to group them into objects and then remove object number 1, or flatten this part, and then remove the first object and then ungroup this, and then you will have your results. That's one way. Totally fine if you want to go that way, if you think that's a lot easier. There's another way, which we can just split the tree. Now you have split list, right? You know this one, which basically just insert an index, whatever number, and then it will split that to A and B. But this doesn't work that well with multiple branches, multiple lists, because then it splits those multiple lists, which is not what we want. There's also a split tree, which is this one with the sort of lightning bolt that strikes down the tree. Now this one works a bit different in the way that instead of the index, what you give into is a mask. And how that works, I think you can probably read that up more if you really want to know the in-depth of splitting masks, which is, I think, a very fascinating component. It does very simple things, exactly what you want, but the way it does it is just it's a bit complex for me to explain in this video. So I'm just going to show you how that works so you have an idea. But first, let's get a param viewer up in here so that we can see what is happening, and we can have 1 to the output. The outputs are positive and negative, which you can see it as a Boolean true-false value. Now, okay, notice our branch, a tree structure, 2 levels, right? The way it works is you would have to enter a similar branch annotation into the mask. The mask is by default flattened, so I would just leave it as is, unless you really want to do some advanced stuff with it, which by all case go ahead if you know what you're doing. But obviously first, the data we want to modify. Now the mask is, if you type in, for example, we want to split this off, what we want to do is we want to type in whatever you want to split off. So for example, for this part, what we have to type in is a curly bracket, a 0, semicolon 0, and closing curly bracket. Oh, the first one is not a curly bracket. This one's a curly bracket. Wait, this one. There we go. And now, if I were to go into the M, you will see the positive are those 4 lines, which are line-like curve, and the other one just goes through the negative. That's one way to do it. In order to make it a bit more simpler for us, because this tree structure could change depending on how you've modify it here. So what we're going to do, we're going to make it easier for ourselves. What we're going to do is simplify the tree. And now suddenly you see there's no positive here because there is no data branch that match this pattern, right? There is no two levels. And the way to fix this, if you just remove one level and leave it 0, we have our split tree working again. So that's in a nutshell how a split tree can work. I believe David Ritter has an in-depth post about this specific component somewhere on the Grasshopper forum, so I would definitely check that out if you want to read up on it more. I'm pretty sure the way I explained it is totally wrong, so definitely check out his post in order to know a bit more about that. But what we can do with this is actually we do the same with the inner helix. Okay, and we should also have 4 lines there, and the rest just goes into the other one. And in this way, we've actually isolated the ones that we don't want to include. So we can actually work from now on. We can just work with the negative part of this tree. Okay, so we mentioned back to the point. We mentioned that we want to isolate the top half. What I can actually do is disable that one so that we can just focus on our major helix. So we want to isolate that part, and what we're going to do is we want to break this into chunks, okay? Because as of now, we don't really know how we can separate the top from the bottom. You can't just cut it and do it that way, which also works. But then we also need to have the points in order to draw our connecting rods. So what we're going to do, sorry. So what we're going to do is we are going to cut it with the very first, in the beginning, we have, I think, these cutting planes, right? So we're going to copy that. We're going to copy that. We're going to copy this too, and we don't need that text, so we're just gonna I'm gonna Control C, and then I'm gonna move all the way here and Control Shift V in order to copy that all the way here, and then just connect the R results to that, and then we have 100 curves. I'm gonna put that up here. 100 planes. So now something is still on. What's on? That part is on. So now what we can do is we can say curve and plane intersection, which is this one, and that one is found under intersection, mathematical, and I believe curve and plane. Where are you? This one, that one. So the first one being the planes, which are the frames that we have here. Oh, go there. And remember to take the N, not the P, into that one. We can disable this one. Okay, so now what we're going to do is we have to modify our data structure. So this one we have 3 branches, but we want to have each item in here to be interacting with all the planes, because we don't know where. Because as far as I know, I think one of these curves is going to full length, or looks like it's going to full length. So we want to have actually each item to be sliced by these frames. And one way to do that is we can start a bit fresh. Let's say we flatten that part and we graph the C part, which means every item will have to be intersected by all 101 frames. If it doesn't intersect, that's fine. Then you get a 0 tree, a 0 item in the tree. As you can see in the first 1, 2, 8 trees, see here. So if you simplify that, you can see a little bit better. And as we can see, we have 14 trees, and that's being grafted here. So what we can do is we can trim the tree down a bit, because we don't need to have that second level. So if we trim it down, you will get 14 branches, which correspond to our 14 elements. And now what we can do is we can shatter it. We can shatter that part with that part. Only problem is we have 13 branches, but this is a flattened list, so we just graph that. And now you have all your items shattered, all your curves shattered. And one way you can isolate the top and bottom now is we need to find there's one thing I miss, and that is the deck item. Can I find that here somewhere? What's this? Yeah, I can use the I-beam for that. Actually, let's copy it from somewhere where we used it before. This one? Yeah, definitely can use that one. So we're gonna copy that, put it on nicely. I don't know, something somewhere at the top. What we need the I-beam for is we might have a use for it later. I'm not too sure. Actually, we do have a use for it because we need to create the horizontal curve. But anyway, so let's do this one. Yeah, let's take the first item and just say CRV evaluation. CRV evaluation. Why is it so hard to type evaluation? Curve evaluation. Parametrize. I don't care which number, so 0. What I intend to do here is to create a plane on the XY axis. It doesn't even matter how the plane is orientated, because we want to use the plane. And then if I can switch to a side view like this, the plane is our deck, and I can use that plane to say, hey, whatever curve is below that plane is going to be sent to different lists. So that's the reason why I use this one instead. And this one is reliable because, well, it comes from the I-beams, and everything comes from the I-beams. So we can actually hide that, put this here, and now we can do for our shattered curve is we can actually use the CRV evaluation with the reparametrize on, but not on 0, but rather on half of it. That way, we can be sure that there's not a single point that will be exactly on that plane. So we can do, I think it was point plane distance. Find the closest point on the plane exactly. I think the plane sample, the plane is that. The sample point are these. Now let's have a look at a tree to make sure they're all neat. That doesn't look neat. So what I'm gonna do, simplify this one again in order to have a neat tree, because I like to keep that neat. That looks about right. Wait a minute. Shouldn't I have? Oh, okay. Okay. Let's have a look at our distance. So obviously minus means they're at the bottom of the plane, and positive numbers means they're on top of the plane. And what we can do with that is we can use an evaluation, okay, and evaluate that to here, and then we can say, oh, what is that? And then for the formula, we can say if x is smaller than 0, which means it's going to be a negative, then let's send that to A and the other one to B, meaning true and false, because we intend to use this on a dispatch. Because we do need the other half at some point, so we don't want to completely call it deleted. Okay, so let's put that here, make sure our tree structure is still good. And for the list we want to modify is actually, oh, let's simplify that one also. But that just means that we don't need to simplify this one, does it? Yeah, it still stays good. So we want to modify that same list. And now, if I do a test on A should be the top one. You can see the top one selected. If I switch to a side view, you can see that a lot better. Oh, something might crash, I think. Yeah, So you can see we only selected the top half. This is the bottom, this is the top. So you can see the top. All right, so with that said, what we can do is we can now apply the same thing to our minor helix, but I have a feeling that we can do that later on when we finish sort of building the block that we need for this upper half, and then we can just copy and paste that to for the lower half. So let's continue on with this. So what we have selected here is all the shattered curves, okay? And now what we want to do is we want to include that horizontal beam. So we can either create it from this, or did we make? We did make it. So should we copy it from here? Well, it's not that hard to remake, so why not just remake it from here? I mean, yeah, I think we've remade that a couple of times that we can just do it like just like that, you know. So let's connect that here, and now we have our beams. And what we want to do with this is actually merge it, okay? Let's actually merge it with our upper curve so that we can have the full package where we, if I can switch it to, I might have to disable a lot of these, so let's, yeah. Actually, I don't want to see that. I don't want to see that also. I don't want to see you too. So now we have only our top curve selected. What we want to do with this is we actually want to intersect it again. Or actually, yeah, we want to intersect it again because now, if I take the picture back up, now we have this one included. We want that point with this point, and so that we can draw that, and so on and so forth. So that's why we intersected this actually twice, and the curve can go in there. The plane can be the same, doesn't matter. Oh, I need to flatten this one first. Big difference here. Now we don't want to follow the order of our lines, but instead we want to have the order that follows each of these intersecting planes. So what we're going to do is we, instead of grafting that part, we just let it flatten. We can flatten there, or we can flatten here, it doesn't really matter, and graft this part instead. And what that will give us is 101 branches with points. If I simplify that, 7 seconds. I don't believe it takes that long. That's weird. Something's wrong with my computer, I think. But as you can see here, if you look at the first level, we have 101 branches. So what we can do now with this is we can actually trim that data back down, and we have all our points. Now what we can do with these points is we can use polyline and then start intersecting them, but we have to sort them, because otherwise what you will get is a lot of random curve. You have curve for sure, but a lot of random ones, and those you probably don't need. So that's not good. So we need to fix that first. And in order for us to do that is we can sort these points along a curve, and that curve can be our circles that we initially used to draw our helix. So let me trace that back. I think we created one here, and for that we needed the outer helix. Actually, let's do that instead. So we can copy and paste that here. I might lower all these down a bit more so that I can keep all the important data that I need to make this happen on the top. That P actually comes from the frame. Now we have all the circles. So now what we want to do is we actually want to further process our circles. For example, moving the seam of the circle, because if you remember, the seam of the original circle is in a position where it's not logical for us. I believe it's in somewhere on this position of each circle, so on that line. And for us, that's just not usable. We cannot use that as a starting point for our polylines that we're going to be drawing. So we have to fix that. And one way we fixed it in the previous part is we just draw a line down and then move the seam to the bottom. But that for us can be conflicting because the bottom can be starting here or there. But we want one definitive position. So what we're going to do is we will actually use one of these two sets of points. And that point, we're going to be using it as a starting point for our circle, is where we move the seam to. So it doesn't matter which one you pick, but I do recommend you pick maybe that one, the one that's the furthest, because we will be needing that part soon. So what we're going to do is do curve closest, no wait, point closest curve. Oh, here it is. And let me see which one is the start. Oh, that one. Okay. So we're going to do those are the points. These are my circles. And I'm going to move the seam of my circles to this parameter. So now if I do a point on curve and I put the 0, it should be there. And it starts going clockwise. So that's perfect. And now what we can do is, well, we can sort our points according to this circle. So we can just sort along curve. If you sort along curve, which is that one, C are the curves and points. Well, we might have to graph one of these, but we'll see. Let's turn that off. I think we have to graph that one. Let's graph this one so that each will be working on that. Let's turn that off. And now, let's simplify this in order to have a cleaner tree. I do fear that we might have duplicate points in here, but let's check that out. So for this to work, you will need to have Kangaroo 1 or 2 downloaded and installed. I have both, but the component I'm going to be using exists in both, so I just recommend you use Kangaroo 2 because that's the latest version. And it's actually this one, remove duplicate points. And we're going to do it here. So if you can see here, input is 906 points and outputs 532. So it definitely called away a lot of duplicate points, which I already also expected because I can already see, for example, in this part here, this beginning point, the plane will cut a point there, which is from this helix, but it also will cut through the horizontal line, which will also yield a point. And those 2 points exist on the same spot, which will give us error in our next step if we create a polygon line. So we definitely don't want that. So let's do culling the duplicate the point away. And now we can put this into a polyline. Well, actually, wait, wrong. We have to remove the duplicate before we sort it because we have a crazy, well, a not neat way of getting our lines connected. Okay. Now you may notice they're missing some lines, but that's because our polyline is not closed. So if you close it, you should have the total package. Obviously, this thing needs a lot of work first. The first being these lines here in the beginning should not be there, same as for the other one. And we have closed our hole for the viewing pod again. So there's a few things we need to tackle in here, and I'm probably running out of time, not sure, but let's see if I can still squeeze this into this part of the video before I end it. What I propose to do is we split this in three parts: the start, the middle, and the end, or vice versa. Well, this one is the end, doesn't really matter. And in that way, we can tackle this, call away these part more easily. The same goes for that one, for the holes that we have to put in for our viewing pods. That way it might make it easier for us, so we'll see how it goes. Actually, there's one thing we can do before we end it, which is, so let's explode our polyline. We can already get rid of the bottom ones because we don't need the bottom one. We don't need it to be there. So we can actually delete that already. And by that, we just use the same trick as we use for separating the top and the bottom. We are going to do a surface evaluation. Curve evaluation, I'm sorry. We parameterize that and put this to 0.5. Close that. Close this. And now we can do copy. I think it's point closest pink. Okay, this one. The same plane is the XY plane. The point's going to be going here. And let's see. Okay. Now our evaluation becomes a bit different in the sense that now points are actually on the plane. There can be points that are on the plane. And the plane, if I can re-enable it and show you, is that one here. So there could be curves that are sitting right on it, or points that are sitting right on it. What I propose to do is, as you can see, this one, this is meters, so this is like 0.0000 something. So yeah, you know what? Let's modify this one in order for us to use the other one. So if I introduce like 0.01 as a tolerance, because I don't think we have points that is that low on distance. 0.01 is actually very small. Oh, I might have to restart my Grasshopper a little bit. Or did we remove a lot of stuff now? Because I remember this one is like 532, which it still is, so that's fine. This one is taking a long time, which shouldn't actually. Even though it's using parallel computing. That's weird. But anyway, yeah, so we can actually reuse same formula that we've defined here and just copy this one actually. And that one can go here. Those are the distances. And then we don't need to use the dispatch because we just want to call it away. We just have to see, okay, that's a false, that's fine. So the pattern goes in here. The ones we want to call is the exploded section. Let's disable our plane. And now you see all the planes that are sitting on the deck is now gone. They are now gone. Although we do end up with the first and the last list being empty, but we can fix that later. The first thing I want to be focusing on now after this is to isolate the three parts that I just talked about. But how do you define which part to freeze is the question. And that I have to refer back to the picture that I took. This one maybe you can see a little bit better. Let's see. Okay, so we're looking at these thicker rods, okay, and let's count them and see how far they go before or how far they are called to. So we have, I think, one here. That's 0. We have one here. So we still have those calls. So we have these. This one is here. We're not looking at the thinner one because we're not doing that one yet. So we can still see it goes around here. And I believe this is where it starts to go down. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 sections before it actually sort of wraps around from one side to the other. 12 sections. And let's think of a logic that uses 12, and I think, wait, distance between helix 4. Of course. We 12 sections actually means that these 4 actually means that each helix begins after it skips 4 sections, and we counted 12, so it's actually 3 times this 4 will give us that 12 that we needed. So we can, I think we've used that even here. We've used that even here before. The 4 comes from this. Yeah. So we can actually use this one. In order to get our 12, in order to isolate that part out of it. Let's cut this and just paste it all the way to the end because it's quite a long journey all the way to the end. What we're going to name here, now we have to move this even more down. This is obviously not helices to call to modify, is it though? No, it's sections to, it's sections to modify, actually. That won't go here, and what we get is number 12. We don't need to call it this. Actually, let's do it. Rods to be called, like that. How about this? Does that make sense? Well, if it doesn't make sense to you, then give it a name that makes sense to you. Okay. Now that we have that, what we can do is we can split this list. Let's simplify, see if we can help that. Yeah, it does help a little bit. So now what we want to do is we actually want to split this list. And the way we're going to do that is we can use a split mask, this one. Because we have the 12, we know which one to split. That's one way we can do about it. The other way is simply to use the tree selection. Both options are valid, but I'm going to show you the option also with the tree band so that you can have a feel as to which one is more comfortable to you, or which one you understand better and are more comfortable using in your own projects. So we're going to be using this one in order to split our tree into the 3 parts that we wanted. So let's start by visualizing our data. Let's have a param viewer here. So we have 101 branches, it says here already. And we want to cut it at the 12, or actually at the 11, because 0 is actually included. And from the bottom, 12 up. How are we going to do that? What we can do is we need to insert a path here. So what we can do is generate a series of indices or paths. It can start 0, that's fine. But when it ends, it should end at 100. Is there any way I can take that number somewhere? Let's do tree statistic. Would that give us something? Which I hope. So these are all the paths. Let's see. Number of paths. Well, that would give 102 though, isn't it? Oh, serious. Sort 0 and okay, that's fine. We can use a tree statistic. I believe we can use that for now. What I want to do with this actually to create list that we can partition so that we can supply them both to like this, so that we can select them individually, each part. Okay, so now with that selected, let's see what we can do. We need a partition list, but we need the partition size. We can actually also use this one, which we have to partition this part actually. So, how are we gonna do that? Let's move this a bit up. So we do know that this is the list we want to modify. Actually, you just want this one. Whether you want this one, that one doesn't really matter. And aha, okay, I got it. Remember that we have the 12 here. Okay, you know what? Let's just take this all the way here. So we have a 12, okay, and so what we can do is we also have, I believe, the maximum. Don't we have that somewhere here? Or do we have it here? Not the number of. Oh wait, we've got it from this C instead, so we're gonna be using that one. So we're gonna drag this a bit more here. What I want to do is create. Let's create an entwine because I don't want the numbers to be messed up. Okay, now that we have that, we can actually use a evaluate command, which takes that number and this number, and the formula is going to be, wait, one is a string, that's a string, oh boy. Let's put a number in front of it so that it gets converted into a number data type. Integer number, that doesn't matter to us. Anyway, what we want to say is 2 times the y being the 12, okay? And then we can say x minus that 12, which would give us 77. And if I were to plug that in here, I'm not sure if this is already enough, but if I were to do a mass addition, actually let's flatten this part and put this here. Do I need to flatten? No, I cannot flatten that. I do need to flatten before I plug into the size, which would give me, aha, okay. The first 12 indices that we need, and then the next, I don't know, 77, I believe, and the last 12 that we need. So we actually don't need that, but we do need this part, and we can actually all hide that. And then what we can do is explode this whole thing. Let's simplify this so that we can have a nice explosion of the tree. Now, the reason I use explode here, which is a component I don't use that easily, is that I do expect a maximum of 3 trees. Even though if the bridge were to be longer, it will still be 3 because I wanted to chop it the ends, the start and the finish, and whatever's in the middle. Unless you have a bridge that has like 3 exits, then it's a different story. But then again, you have to change the whole script in order to accommodate that. So this will probably never change. And now I can safely go ahead and say I want to select the first part. There we go. Or actually, let's delete that one. Let's create 3 of these. Or I want to select the middle part, which is this one. Or how about the last part, which is that one. So now this gives us actually the flexibility in order to modify whichever we want and however we want. So let's test this one. Remember we have one here that is not counted. Oh, actually that one is not counted at all, isn't it? Or is it? Wait, let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, so it is counted to it. Okay, that's fine. That's fine. Now what we can do with this is actually remove the first item. Because I do believe that let's actually test whether the first item is that long curve that we don't want. Oh, oh. Huh. In some part it is, but in some part it's not. I wonder why. Even though we've sorted all the points, and it's still not the same. So now we have to go back and figure out why I am not selecting the first curve that I expect to have. Even though we've sorted this. Or perhaps just sorted points or not. Wait, let me see. Let's do a point list. This is going to be super heavy for our computer. Or not. Huh, interesting. 1.3. Wait, what? Huh. Oh, I see. I see where the problem is. I can actually give you a minute to guess if you want to. So if you want to guess, I would say pause the video now and try to guess if you can find it. This could be a good test for you. But obviously, I'm gonna wait. I'm not gonna wait 1 minute. You can just pause the video. But the problem lies with this particular component, because remember we said I want you, okay, to move the seam to the point. Where's it? Point on curve. And what we actually did is we did move it, but who's to say that, let me enable the counting number again, but who's to say that it should sort the number starting from that point where there's also a point of the curve, as you can see here, or the next point that it encounters along this circle, which in some cases are these top points. Let me disable that circle. Let me see however. So for some points, yeah, for some points, this is the middle. But what is to say that, hey, I can't see this point, but if I go along the circle, I see that point? Because that's exactly what we did here. We said sort along this new circle that we moved the seam to, which happens to be right along this edge. But what we actually want to have is all these to be zero, so that we can say, okay, the next curve, which is always going to be that one, will be culled or will be deleted or whatever. So how can we do that? How can you fix that? Well, it's a simple fix. Is remember that we've used a parameter in order to find this point, in order to move the seam. So imagine this is the point that we set, right, in order to search from. What we can do in order to help the computer is say, hey, that parameter that you have, and we know it's going clockwise. That parameter minus a tolerance 0.1 or whatever you want, just nudge it back a little bit so that it can all start here, so that it will always see this row of point first, and then the result of that, it will label that is index number 1. Now let me put this into an evaluation so that it can be easier for you to see later on if you do decide to see that. I'm gonna actually do this very explicitly, like here, and then we are in meters, so let's add a, I don't know, 10 centimeters helper for sorting, something like that. And then our formula is going to be x minus y, because we want it to go down. So once observe, look, keep your eyes on the index, the point index on this row. Watch how they all magically become a 0. So these are like very little neat trick if you understand the parameters of curve. It would be even nicer if you can understand the parameters of surfaces, which acts in the same way except that it has 2 dimensions. But, and now, what we have is we are selecting the first one. But we don't want to select it, we want to call it. And that becomes a lot easier for us to just say, I want you to call index number 0. There we go. Simple as that. And then we can do the same for the other end, except that now remember that it's been reversed. So if you call this one, you'll be deleting the wrong curve. So what you need to do is reverse it, and then you have it. Easy as that. One thing we want to check about is, remember the pictures we said it's, I think the 3rd section, meaning where the other major helix starts. So we can actually have a check on that before we end this video here, because I think the next part explaining about calling that, we can move it to that one. Then we can easily just duplicate this and use it for the minor helix. So that's what we're going to say for the next part of this video. But first, let's check on our, what's that? Is that a deck? Yeah, that's our deck. Let's check on our, see if we've done it right. And yes, in the 3rd, or is it the 3rd? Wait, am I doing this right? Is it really the 3rd? So we're skipping 12. So we have skipped. Let me see. Actually, I want to open the I beams. Are these the I beams? Oh, that's the one. Yeah, that one can be opened. Where are my I beams actually? Oh, there. The I beams color is really way too dark for us. So what I'm gonna do is tone it a little back like that. But what I want to check is, so it's skipping 1, 2, 3, 4, 5, 6, 7. Oh, I can actually count it. 1, 2, 3, 4, 5, 6, 7, 8. I lost count. I can't believe I lost count. 2, 4, 6, 8, 10, 12 sections before it takes that. So let's go ahead and count our own with different color. So we have 1 here, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 before it begins again. So we have successfully fixed the end and the start part. I probably should end the video here. I'm thinking this is a very long video now. But in the next part, what we're going to do is we're going to quickly go and fix the holes for our viewing part. And we're going to copy this whole script and then give it to our minor helix so they can have the same treatment. And afterwards, we're going to fix the bottom one. And then probably the last part, which are these interconnecting interhelix connecting support rods for the very final part. So I hope you understand this part, because it is a bit tricky since we've introduced a new element, which is the split tree, and a lot of grafting going on, a lot of precise ordering of tree that we've done here. So I hope you can still understand that, still follow me this far. And in the next part, we're gonna be we'll try to finish all the support rods. I thank you for watching, and I hope to see you again in the next video. Have a good one.